Converting between systems. So we have two different systems that we use on a daily basis. We have the metric system, which is when measurements are related by powers of 10 using prefixes. So when you're using the metric system, you're basically just moving the decimal to the left or the right to convert between different units. So for length, we use meters, for volume, we use liters, and for mass, we use grams. And you can see that we've got these squiggles in front, so it'd be something like centimeter or milliliter or kilogram, kilogram, kilogram. So these prefixes tell you what base of 10 you're going to be using. The US customary system is what we're most used to. It's based on the English system of measurements, so things like inches, feet, ounces, pounds, cups, gallons, etc. So what we're going to do is a process called dimensional analysis. Dimensional analysis is the process of including units of measurement when you compute. So whatever starting unit you have, that goes in the denominator of the adjacent fraction in order to cancel those units, and then you're going to multiply all of those fractions together and simplify in the end. So you should have a measurement chart that looks similar to this. This is what we're going to use when we're converting. So if I have 6 inches to centimeters, if I look at my chart, you can see that I have over here 1 inch is the same thing as 2.54 centimeters. So if I'm starting with my 6 inches, I have 6 inches. Make sure you put units. It says that whatever I'm starting with, that goes in the denominator of the second fraction. So that unit of inches, and since I have a direct conversion, inches to centimeters, I'm going to put my centimeters on top. Again, according to that chart, I have 1 inch for 2.54 centimeters. So 1 inch is going to give me 2.54 centimeters. Now that I have my first fraction, I can cancel out units. What you have in the top and the denominator can cancel out. So now I'm just going to multiply across. Remember, you can put anything over 1 without changing it. So 6 times 2.54 is going to give me 15.24, and my unit is going to be centimeters. 1 times 1 is going to give me 1, so I don't need to put it in the denominator. If we move on to the next example, it says how many seconds are in 1 hour. So I know that I have 1 hour, and I'm looking for my seconds. So in 1 hour, you can break this apart. So if I know hours go to minutes, that's my next smallest unit, and then minutes go to seconds. So I'm going to kind of do 2 steps for this one. So my hours is what I'm starting with. That goes in my denominator. So for 1 hour, I have 60 minutes. My hours cancel what I have on top and bottom. So I'm going to set up another fraction to go from my minutes to my seconds. So in 1 minute, I have 60 seconds. So now my minutes are going to cancel. So the only unit you have left is the seconds, which is what I'm looking for. So my answer is going to be in seconds. And I know that 6 times 6 is going to give me 36. And I have 2 zeros that I'm multiplying also. So there are 3,600 seconds in 1 hour. Okay, if we move on to slightly more complicated ones, I have convert 5 pounds to kilograms. So what I have my 5 pounds. If I look at my chart, if I'm going pounds to kilograms, that's a mass. So down here, I have 1 kilogram is the same as 2.205 pounds. So if my pounds are on the bottom, my kilogram is on top, because what you start with has to go in the denominator in order to cancel out. So in that chart that I showed you, it said that 1 kilogram was 2.205 pounds. So now, again, your pounds cancel. So when you multiply it through, I have 5 kilograms on top, and I have the number 2.205 on the bottom. When you write these answers, you cannot have fractions, so you're going to now divide it. So 5 divided by 2.205, when I plug it into a calculator, you end up with 2.27 kilograms, about, because I rounded. So pay attention to what they're asking you to round with in your questions. If we look at example 4, it says how many cups are there in 3 liters? So for this one, that's a measure of volume. So I'm looking for cups and liters. So as you can see, I don't have a direct conversion between cups and liters. However, I have over here liters to pints, and then over here I have pints to cups. So I'm going to do 2 fractions like I did previously. So I'm going to start with my 3 liters. Well, I'm going to go liters to pints and then to cups. Sometimes it's helpful to kind of set up your plan of attack, we'll call it, or your process, so that you know what each fraction is going to look like. So I have 3 liters, that's what I'm starting with. My liters go on the bottom, my pints on the top. If you look at that chart, it said that there was 0.473, so 0.473 liters for 1 pint. So now I can cross out my units, my liters. So now I have pints, and I want to go to cups. So again, pint on the bottom, cups on top. So for 1 pint, I have 2 cups, according to that chart. So when I cross them out, and I multiply across, so 3 times 2 is going to give me 6 cups. 0.473 times 1 is 0.473. And remember, now you have to divide, and then you're going to round. So you're going to end up with about 12.68 cups. It is very important to keep your units so that you keep track of what your numbers are doing. And the last one says that an Olympic-sized swimming pool is 50 meters in length. About how many feet is this? So you're going meters to feet is what it's asking. So that's a measure of length. So you're going to look at these top 3. I don't have a direct meters to feet. So you can kind of do this a multitude of different ways. You can go from meters to kilometers, and then kilometers to miles, and miles to feet. You can go from meters to centimeters, and then centimeters to inches, and then inches to feet up here. So that's the one that I'm going to do. So I'm going to do meters to centimeters, and then to inches, and then to feet. So you're going to have 1, 2, 3, 4 fractions. So what I'm starting with is 50 meters. That's going to be my first fraction because I can put it over 1, times, according to my chart, in 1 meter, I have 100 centimeters. And then your meters are going to cancel. So now you're going to look at centimeters to inches. So if centimeters were on top, going to be on the bottom, inches. According to your chart again, for 1 inch you have 2.54 centimeters. Your centimeters will cancel. What you start with, inches on the bottom, feet on top. For 1 foot, I have 12 inches. So when you're debating what numbers to put in front of what variable, you need to reference your chart. So in here it says 1 inch equals 2.54 centimeters. So that's why I have my 1 in front of the inches and the 2.54 in front of my centimeters. If we were looking at meters to centimeters, it says that 1 meter has 100 centimeters. And the same thing, 1 foot has 12 inches. So the 1 isn't always on the top or on the bottom. It all depends on how your fraction, where your units are. So that's why you need to make sure you include those units. So now, again, my inches cancel. So I'm going to multiply across. So 50 times 100 times 1 times 1. 5 times 1 is 5. I have 1, 2, 3 zeros. And my final unit on top is feet, because everything else canceled out. In my denominator, 1 times 2.54 times 12 is going to give me 30.48, and you have no units left on the bottom, so it's left blank, so that's why we have to divide. So now 5,000 divided by 30.48 is going to give you about 164 feet. It's closer to 164.5 feet, but either of those is correct.